Hello there, kitties. I'm Carrie, the vacuum tube witch with a little reverse engineering project because I got a sound card named Maya 1010 from my friend, and the problem with this sound card is that I don't have the breakout unit for this DB45 or 44 connector. That is the analog connector, and I need to figure out what's going on and which pin is for the output and which pin is for the inputs, because this card has it has 8 analog outputs and 8 analog inputs, and it also has 2 digital outputs and 2 digital inputs. And there's hardly any information on this card to be found on the internet. There is no pinouts, there is no schematics whatsoever. Only thing I found was the instructions manual, and I've got some interesting excerpts from it, and the rest I have to do myself in order to use the card, in order to connect it with any signal sources or amplifiers. I have to figure out the pin arrangement on this sub-miniature connector. So let's get down to the business and see what's there, what's on the board, and where it all is routed. Okay, let me switch the camera now. Okay, so we are now at the bench, and what I found for this camera, it's the circuit diagram. It's not exactly the circuit diagram, but it's a block diagram. It says that it has 8 analog inputs here, and the first pair of inputs can be on microphone level or the line level, and it has an adjustable block of gain or attenuation here, and the preamps. So I expect those inputs to be a little bit different when it comes to the circuit design than the rest of the analog inputs here. There is also a SPDIF coaxial input that would be routed to this port, and there are 8 analog outputs that would be normally they would be line level, and the last pair of outputs, the number 7 and 8, would be able to drive the headphones. And the routing of the signals is a little bit different here. And what I can also figure out is that the parameters of the card, the analog inputs quarter-inch female TRS type balanced or unbalanced. So I would expect a pair of signal lines on the port and a ground port for each of those inputs. The ground ports might be wired together. Input impedance 10 kilo ohms minimum. So probably if I measure the resistance between the input port and the ground, it will be something like this, maybe a little bit more. It might also be infinite, and that happens when the input is routed through a capacitor. That would make the DC resistance a lot larger, if not infinite. Depends on the circuit design. And analog outputs, all of the analog outputs are unbalanced, so that would mean that I would have only 8 output signal lines on the port. And the output impedance is 100 ohms. This is usually the serial impedance or resistance for the output stage, like an operational amplifier or something like that. Microphone preamplifier parameters and headphone amplifier parameters. It can drive up to 32 ohms headphones. Of course, the 600 studio headphones are always also supported, and they take less power but need more voltage to drive. 125 milliwatts at 32 ohms. Digital audio, it doesn't concern us as much. Analog to digital converter and digital to analog converter. Digital inputs, it's not that important to me, because what I want to do is reverse engineer the analog part. And here we've got the view of the breakout box. It's the part that connects with this sub-miniature connector here. And that would mean that the microphone inputs here and here, they would be a pair of inputs supporting the plus 12 volt phantom power. And all of them here, it is line inputs. Here we've got line outputs, the regular one. And here we've got the headphone outputs. Probably the stereo headphones here. Not sure if the outputs are mono or stereo now. And the first part of the reverse engineering project, it should always be the research on what you are dealing with, gaining as much information about the circuit as you can, because it will make the whole thing a lot simpler when you actually know roughly how it works. And basically what I'm gonna do now is drawing this miniature part and trying to determine what is found there. So here we've got 3, 6, 9, 12, 14 pins. $15. And 15 in this row as well. And what I can do now is checking which one of those pins has a ground connection. And let's also note that this is the view on the plug soldering side. And there are also markings for each one of the contacts. Here we've got 1 and here we've got 16, 31, 44, 15, and this would be 30. So let's move on to finding the ground. Beep. Start from the lowest number, I think. Ground on number 4. Number 9. And number 14. Move on to the next row. $17. $27. And the third row. $35. $40. And that would be it when it comes to the ground connections. So it looks like there are 7 ground connections on the port. That wouldn't be a ground connection for every input and output line. So I wouldn't expect that there is a multi-pair snake cable, from the from the stage sound systems. Those cables have every pair of wires because they have multiple twisted pairs individually shielded, but I wouldn't expect it here, given that there are just 7 ground connections. Okay, so now it's time to determine which one of those is the input and which one of those is the output section. And I think here we've got HC4053A integrated circuits, some op-amps here. Those are, let me see, JRC 4580. And all of the op-amps here, they are also JRC 4580. There's another HC4053 here, HCT541 here, and when I took a closer look at the traces going to this connector, there are like 4 traces going all the way to somewhere like here. I think they would end up at HCT541. And if we take a look here, we've got a bunch of electrolytic capacitors. Probably for the power circuit 317BJ, that would be an LM's 317 voltage regulator. Some more electrolytic capacitors, 350BF, probably an LM 350. And here we've got 2 transistors or ICs, U25, U24, that would be ICs, and the markings on them are 7809A and 79M09A. Those would be the typical Jelly Bean linear voltage regulators for the positive and negative 9 volts, probably for powering the operational amplifiers. Here we've got a bunch of surface mounted resistors and capacitors and D16, D12. Those would be double diodes, I think, because they are not marked Q but D. And here we've got some actual transistors, not transistors, that the marking is 2AN. The SOT23 package. And those are different types of transistors. 1AM, which suggests that they might be some popular parts. One of them is the PNP and the other one is the NPN type. And we've got a bunch of resistors and capacitors here. Looking for repeating patterns. Looks like there's a bunch of those RCs for every one of the channels. Okay, so I think that would be it for now. And reverse engineering the device, it's gonna take some time because I have to poke around this board with the multimeter and see what is routed where. Because with this white solder mask you can hardly see the traces. You can see some of them and get a rough idea of where things go and where things come. And it might actually be helpful with identifying the pins being the output and the input. It would be also useful to find which one of those pins routes to which one of those contacts here. This looks pretty intuitive because the number 15 here, I think it would be this. Let's confirm it. Indeed it is. So the top row here would be the row closest to the connector here. And the way those connectors are built inside, it is pretty intuitive, like the top row looking from this direction would be the farthest from the edge of the connector, and the bottom row would be the closest. It's all bent with a 90-degree angle inside. So okay, that would be it for now. See you in the next episode. And be sure to like, comment and subscribe. Bye!